Okay, this is an introduction for the activity to find the quotient rule. So this time our big function, capital F of x, is going to equal f of x divided by g of x. So I'm going to set this up the same way. F of x equals 4, g of x equals x. So if my function is 4 over x, using my simple power rule, I can think of that as 4 times x to the negative 1. So my derivative of that will be negative 1 times 4 x to the negative 2, which I can then rewrite as negative 4 over x squared. So 4x to the negative 1 becomes negative 4 over x squared. So we want to see if we can get that with as few as parts possible. Derivative of 4 is 0. Derivative of x is 1. So I have negative 4 over x squared. So I need a negative 1 times, so negative 1 I guess would be negative g of x. Negative g prime of x. So negative g prime of x is negative 1 times f so derivative of g times f, and then over g of x squared. So I have an x squared, so that's just g of x squared. I have a negative 4, so you could say is negative g prime times f. So that'll be my formula. And again, you can fill in all those parts and see that that works. You can pause this and work out the rest of the activity on your own or go part by part. I'm going to go on to part 2. And I'm going to copy this as well, since it says I'm supposed to start with that for the next time. All right, for set 2, f of x is still 4. G of x is x squared. Last time it was 4 and x. This time it's 4 and x squared. So the derivative, if I think of this as 4 times x to the negative 2, my derivative is going to be negative 4 times x to the negative 3, or negative 4 over x cubed. So again, think of that as 4x to the negative 2, and that's not quite right. If it is 4x to the negative 2, it's going to be negative 8 x to the negative 3. So negative 8 over x cubed. If I look at my derivatives, the derivative of 4 is 0. The derivative of x squared is 2x. If I start with the expression I had from last time, the negative g prime of x is negative 2x times 4 over g of x squared. G of x is x squared squared. So that'll give me negative 8x over x to the 4th, which is negative 8 over x cubed. So I still just did negative g times f over g of x squared. And it could have been that on set 1, when we did this, instead of having the negative g prime, you just had the negative times f of x. So you may not have had this part to it. You could have just had negative f of x, so negative 4 over g of x squared. So if that was your part on set 1, that explains now we added a piece on set 2. If for set 1 you said negative g of x, then set 2 we didn't need to add a piece, we were able to use the same equation. So let's go on to set 3 and see if we can still use the same equation. And so I'm just adding a power here for the g of x, if you can see that. So now I'm doing 4 over x cubed. So that I don't make a mistake, I'm going to rewrite that as 4x to the negative 3. So f prime, capital F prime is negative 12 x to the negative 4, or negative 12 over x to the 4th. Derivative of 4 as my function f is still 0. Derivative of x to the 3rd is going to be 3x squared. If I start with my pieces, negative g prime of x is going to be negative 3x squared times f of x is times 4 over g of x squared. X to the 3rd squared is x to the 6th. And that's going to give me negative 12 over x to the 4th. Again. So I still have not needed to add anything to my expression. Negative g prime of x times f over g of x squared. So for the first 3 sets, I've been using the same formula. So it could be that we have our formula. Negative g prime of x times f of x over g of x squared. So let's do one more and see if that holds, because it also could be that it's working because the derivative of f is 0. Since we've been using a constant function, maybe we're getting lucky. So let's try it where f of x is not a constant function. I'll try to keep it simple though, so I made f of x 4x and g of x 2x. So f over g is 4x over 2x, which simplifies to 2. The derivative of 2 is 0. So I need a formula that's going to give me 0. The formula that we've been working with is this. So let's find all of our parts. F prime of x is 4. Or sorry, f of x is 4, f prime of x. F of x is 4x, f prime of x is 4. Man. G of x is 2x, so g prime of x is 2. So using the parts that I have, I need negative g prime times f of x over g of x squared. So that's going to be 4x squared. So right now that's going to give me negative 8. Let's see if I simplify this more. So negative 2 over x. I have negative 2 over x, but I need it to be 0. In order for it to be 0, I really need a 0 on top of the fraction. So instead of looking at it as canceling out, I could look at it as I have a negative 8x on top of the fraction over a 4x squared. So if I can get a positive 8x to add to that, I'll have it. Well, the positive 8x is going to come from, let's see, we've already used g prime and f. What if I use f prime and g? So if I take my expression here and I add to it f prime times g, then I'll have negative 8x plus 8x, which is 0, which is what I wanted. So that is the quotient rule. It's the derivative of the first function times the second minus the derivative of the second function times the first, all over the second function squared. You need to know these well, your product rule and your quotient rule. And so you can look through some of the examples and try those out. And then when I get back to class, we'll touch base.